Welcome everyone. Thank you for joining us today's Minitab webinar. Topic is Gage repeatability and reproducibility, Gage R R. I'm now Sulawati and I'm technical support specialist at Visit System. Visit System is an independent local representation for Minitab product and training in Malaysia, Singapore and Batam, Indonesia. Okay. Before we get started, there are a few housekeeping items to take notes. If you have questions during presentation, please type them into the question box in your control panel. You may send in any time throughout the presentation, but I will address them during Q&A session at the end of webinar. Kindly ensure that you have connected to the audio via your computer speaker. Please fill out our survey before you exit the tab. This survey will help us to improve the quality of our upcoming webinar. For your information, this webinar will be recorded and therefore it will be set as listen-only mode to avoid interruption to the audio recording. The recording will be accessible anytime later on our website www.visits.com or by subscribing to our YouTube channel, Minitab Malaysia and Singapore. Okay, Minitab was developed in 1972. We just released Minitab Statistical Software 90.2020.1 in last 7 April. But those are new with Minitab. We are statistical software where everyone can use, whether you are a statistician or non-statistician. Okay. Minitab Statistical Software deliver business and predictive analytic pair with accession visual to enable data-driven value-creating decision making. So our new tagline, better decision making, faster performance, easier than ever, now with a cut. Okay, Minitab offer various type of analysis. If you are coming from quality side, maybe you are familiar with the measurement system analysis. What we want to learn today, we want to share with you today is about the Gage R R, repeatability and reproducibility. Okay, inside there we have a features like say Coprical, and then inside the MSA we also have the gauge linear and bias report, and then we have a control chart, not the only basic control chart. We have a let's say G chart, T chart, so advanced control chart, and then we have a capability analysis where you want to study about the capable of your process after your process in control state. Okay. Beside that, we have also for reliability engineering. Let's say you want to know about MTBF. Okay, you want to study about accelerated life testing, and then inside there we are a lot of distribution. Okay. For example, your data is not normal, so how to handle it and then how to identify, so you can using the reliability engineering. And then for the product development, maybe you are from R&D department, maybe design of experiment, not only for factorial, we have, let's say, RSM, response surface experiment, or we have also, let's say, screening before you do the factorial design. Maybe you have a lot of the factor, so you just do it the screening part. Okay, inside there we also have the main plot, okay, Pareto chart to know the significant factor. Okay, and then is, let's say you are coming from the business oriented, okay, business department, maybe you are familiar with the correlation side, which is want to, before you do the modeling like CAD, classification and regression tree. So you need to know about the correlation for each other, okay, for each factor of each variable. So we also have the multivariate. If let's say you want to, let's say, workgroup your data, okay, maybe you can using the PCA, principal component analysis, and then if your data a time database, so you have time series, so we up to ARIMA models, okay. And then if let's say you are we want to do the process validation part, maybe you're starting with the process design with the graphical side, and then go for the process qualification, maybe you go for the control chart or go for the tolerance, and then you want to do the continue process validation, so maybe you can go for the acceptance analytic. Okay, so all these functions are available in Minitab statistical software. Okay, this one is the some our customer have been using Minitab, because we're not limited to the manufacturing industry, but we also be used to others industry like services, DHL, finance, and academician. Okay. So our agenda today is we go through when we talk about the measurement system analysis, a big topic. Inside there we have Gage R R. So today we just focus on the Gage R R, Gage repeatability and disposability. So this measurement system are related with the two terms, is it precision and accuracy. Okay, but today I just proceed with the Gage R R, which is related with the precision side. Okay, and then I will to show how to create the worksheet, how to analysis, how to interpreting, and then after that we have a features like assistant help you to easy do the report or easy to interpret the result. Okay. So it is essential to make sure that your measurement system, like your gauge, okay, your workers, your method, your machine, your procedure is stable and capable of measuring your data before start gathering analysis data to make the decision. Okay, if your measurement system is not acceptable of producing reliable measurement, then any analysis you conduct with those measurement is likely meaningless. Let's say you already have a control chart, but you're not sure your gauge, your machine is reliable. So that's why it's not good, or your control chart is not reliable to do the decision maker if your measurement system is not stable or is not acceptable. Okay. So during the assessing variation in measurement system, we have a two term. I think this one is during we secondary school, we already know about the accuracy and precision. So this time around, maybe this one is application for us. Okay, so I just remind again, accuracy is how close measurement are to the true value. For example, you make sure the potato bag make sure if 5 grams, so you need go have a true value, means that 5 gram. Okay, the differences between the part measurement and actual value. So the component inside the accuracy, we assess about the bias, linearity, and stability. But today we not focus on this accuracy side. We just go for the precision. If let's say you are interested on this bias, linearity, and stability component inside the accuracy, maybe you can sign up our training, statistical quality analysis training. Okay. For the precision is how close measurement are to each other. The variation when the same part is measured repeatedly with the same device. So component inside the precision, we assess on the repeatability and reproducibility. So maybe this graph picture easy uh, to understand about the accuracy and precision. So inside here is we have accuracy and precision. So this one is we call it precise but not accurate, because this one is our target dot. Okay, and then this one is accurate and not precise. Okay, and then this one is both not either accurate or not precise. Okay, so this one is sources of variability. Okay, inside the observation process variation, we have an actual process, is we call it part-to-part variation. Okay, and then what we want to do today is focus on the measurement system, but inside the measurement system variation, we just focus on the precision part, which is repeatability and reproducibility. So the others we not cover for this webinar. Okay. So gauge repeatability and reproducibility is a Gage R R. So I think I just using coding acronym is Gage R R. Gage R R is a methodology used to define the amounts of variation in the measurement data due to the measurement system. So you recall back, the measurement system include the gauge, personnel or workers, method or procedure. So but repeatability is the variation observed when the same operator measure the same part repeatability with the same device, which is let's say we have a three factor here. We have operator, we have a part, we have a device. So all that thing is at the same person, the same part, the same device. So it's which is we study on that repeatability. Okay, if let's say reproducibility, the variation observed when different operator and measure the same part using the same device. So meaning that the reproducibility is a different operator. So easy to us remember about this thing is O here. O is maybe refer to operator. So reproducibility refer to different operator. The same part, the same device. Okay, basically, Gage R R we assess to know how well the measurement system can discriminate between the parts and then whether the operator measure them consistently. Okay, so I think we get something. Wording here is repeatability, refer the same operator, same part, same device. For the reproducibility, different operator but same part and the same device. Okay, so this one is the how we do the experimental or we do the worksheet. So let's say you have a part here. So you have a 10 part here. Okay, and then you have a 3 operator. And then every operator repeat for 3 times. Okay, so this which is the variability from the repeated measurement by the same operator. And then from here, okay, reproducibility when the same part is measured by different operator. So which is in reproducibility, we have operator and then we operator by the part. Okay, so this one is how we do the experimental. First you have a 10 part, you have a 3 operator here, and then you repeat for 3 times, which is now you have a 90 runs. Okay. So this one is we can using Minitab to create the worksheet before you done your experiment. Okay. So this one, if you are new for Minitab 19, so this one is the new interface for Minitab 19. Okay, before I got show the worksheet, so I think I just refresh some enhancement for from the old version to the new version. So now in Minitab 19, we call this one is a single interface where your data worksheet here, your output pane here, and then you have a navigator. So in the worksheet, basically in this interface, you can zoom in, zoom out, or you can simplify, let's say you just only proceed with data only, or you want to have something like data and output, or you don't want is a navigator, so you can manipulate on this new version for Minitab 19. Okay. But if let's say you want to know about more enhanced, so maybe I encourage you to visit our website www to get the previous webinar regarding on the enhancement of the Minitab 19, or you can go through to our YouTube channel Minitab Malaysia and Singapore. Okay, so we go back to the actual agenda today. So how to create the worksheet? Okay, how to create the worksheet? So you go for the stat. Okay, you go for the quality tools. You go for the Gage study, and then you see that here is a create. Here is a create. Sorry, go to study Gage and R. Create the Gage R and R. Okay, so inside the dialog box, you need to decide how many number of part you have, okay, and then how many operator you have, and then if let's say you have a part name, so you can rename in the part name. If you have operator names, you can rename the operator name here, and then how many number of replication. For example, I just proceed with the 10 part. Okay, I have a 3 operator here, and then maybe I have the name operator here. Okay, okay, okay. Maybe Susan. Okay. And then I want to do the 3 replication. So click OK. So now you get the worksheet. Inside the output pane, they provide you how many part. You have a 10 part. You have 3 replicate. You have 3 operator, and then the total runs you 90 runs. So this one. So if let's say you have a measurement, so you just put where is this a measurement. Okay. And so on. Okay. So I repeat again. Go to stat. Okay. So sorry. Go to stat, go to the quality tools, go to Gage study, go to the worksheet create. Okay, so you include the number of part, number of operator, and then if let's say you want to randomize or not randomize, you go for this one. If let's say you don't want, do not randomize, so you go for the do not randomize. So if let's say you want to randomize, you will have a random number, so you can set it up for the option 1. Okay, and then click OK. So you get this result. Okay, so this one is how you want to create the worksheet. Okay, how do you create the worksheet? Okay, so we go for another one. Okay. Okay, type of analysis for Gage R and R in Minitab, we have a 3 type of analysis. The first one is the cross Gage R and R study. Cross is each operator measure each part. Okay, so we have a second analysis for Gage R and R. We call it nested Gage R and R, which is your each part is a unit to the operator. No 2 operator measure the same part. So one operator measure one part only, not have a, let's say for the cross, every operator measure the same part. So maybe nested maybe is for the disruptive testing. Okay, and then for the expanded is you have a more than 2 operator. Basically, we have a operator, we have a gauge. Okay, we have a part. Maybe you have another factor. Let's say your location, something like that one. So you can go for the expanded, where in the expanded you have an unbalanced design. We call it the unbalanced design. Okay, so in your mind right now, for Minitab Gage R R study, we have a 3 cross, we have nested, we have expanded. So, but today we just focus on the cross Gage R R study. Okay, if let's say you have a problem with the nested or you want to learn more about nested and expanded, maybe you can join our training session, okay, to get the more detail today's, okay. So this one is the differences between cross and nested. Okay, so every operator, which is measure every part. This is all this one, part one until part six. So same goes for the operator two. But for nested, they have a divide. For example, operator one just measure part one until part three only. And then operator two measure part four until part six. So this one is the differences between cross and nested. Okay, so today I have one case study here. Okay, a manufacturer of fuel injector nozzle install a new digital measuring system. Okay, investigator wants to determine how well the new system measure the nozzles. They code the 9 nozzles to identify the measurement taken on each nozzle. Each operator repeat or the process twice for a total 66 measurement. The specification for the nozzle diameter is 9013 plus minus 5 microns, and the tolerance is 8 microns. So I think I go for that data set. So which is they have 9 nozzles, 9 part. They have repeat 2 times. Okay. So I go for this one. Go for that data set. Okay, so this one. Okay, so in the randomly, is it? So they have a two operator, which is operator one, operator two. They have a 9 part. Okay, one is this one, 9 is the bigger one. Okay, and then they repeat for 2 times. Okay, which is now they have a 636 run. Okay, so how to decide which analysis is fit with this case study. So we have a two operator, which is they have a 9 part, and then every operator measure for every part. So which is they are available for cross uh, analysis. So where? Go for the start, go to the quality tools, go to the gauge study. And then you see that here is we have cross, we have nested, we have a expanded. So for every details, they mention what is a cross, what is the expanded. But today I just proceed with the cross. Okay, I go back, go to stat, go to quality tools, go to gauge study, go to cross. And then inside there, have a dialog box you need to fulfill. The first one is a part number. For this case, we consider that is a nozzle or our part number. And then operator is operator. For measurement data, we call this one is diameter. Okay. And then in option side, because we provide the tolerance, so you include the tolerance here is a 8. Okay. Click OK. And then click OK. So you get the result for Gage R R Study, where you have a ANOVA table, you have variance components, okay, you have a gauge evaluation, and then you have a report, let's say in graphical report. So a lot of the information inside the output we generate from this analysis. But after this, I will show step by step to interpret when you want to start it. Okay, but I go back to the how to get again. Okay, stat, quality tools, okay, gauge study, Gage R R cross. Okay, so you need to fulfill the nozzle, your part name, okay, part number, sorry, your operator, your measurement. If let's say you have option, you have, let's say you just have a tolerance, you should include tolerance, okay? And then for information here, if let's say you have a historical standard deviation, so you include in historical standard deviation, okay? If let's say you want to have a graph on separate graph or one graph per page, so you tick here. So for example, I just proceed with this one, click OK, and then click OK. So you have a something like this one. Okay. This one is the first. This one is a different one graph in one pages. Okay. So this one. This one is the component of variation. Okay. Your diameter. This one is the interaction. Okay, this one is for everyone, or you can get the in one graph you get have a 6 picture in one graph, or you want to have different layout for the graph. Maybe it's one, this one is easy to do the interpreting, or you want to easy to you to see the result. Okay, so we have this one. So I go back to my slide again. Okay, so this one is, I think this one is the best for those are new with the Gage R R. Okay, so inside the ANOVA, we have a table, let's say, to identify the sources of variation, where inside the ANOVA table, we have a part, we have operator interact with the part, and then we have error. Okay, inside the use the Gage R R table, you can get the total Gage R R, you can get the repeatability, you can get the reproducibility, you can get the part to part. Okay, so inside the table, you can get the percentage contribution, percentage study variation, percentage tolerance, and NDC. Okay, and then inside there, the graph, you can get the component of variation, you can get the R and X bar chart, measurement by part, measure by operator, operator by part interaction. So this one is a lot of output, but I think one is the help you to do the best decision. Okay, so if let's say you want to do the interpreting for each part of the result inside the Gage R R, so I think the best thing is you need have some like guideline. So many expert or many researcher using the AIG standard is automotive industry action group, or we call it AIAG standard. So meaning that is based on the percentage. If you are looking for the percentage contribution, if let's say 1% or less, so they say that system is acceptable. If let's say 1% to 9% is potentially acceptable. It depends on criticality of the measurement of cost or risk. And then if let's say your percentage contribution more than 9% or greater, so we consider that the system is not acceptable. Okay, so if let's say you want to go for the Gage R R table, so maybe you are looking for percentage tolerance or percentage study variation or percentage process variation. So it's, let's say you go for the tolerance study and process percentage. So maybe under 10%, you consider that is acceptable. If let's say 10 to 30% is, let's say is potential acceptable, is over than 30% is not acceptable. And then others thing, we go for the number of distance category, or we call it NDC. If let's say 5 or more, system is acceptable and distributing between the part. Okay, so what is the percentage contribution? Okay, percentage variation is due the sources compared to the total variation, but with the added benefit, there are sources with the sum of 100%. But today I just play around with this guideline, not show you how they get, how they calculate to get the percentage tolerance, how to get the study variance, and then how to get the process. Okay, so but this one is AIAG standard or guideline is less than 10% is acceptable, 10 to 30% is potentially acceptable, is over 30% is not acceptable. Okay. So I go for the ANOVA table here. For information, Minitab will provide you a second ANOVA without interaction. If let's say you see that is a nozzle, interact with the operator, is the p-value is more than 0.07, so we consider is not significant. So this interaction not include to our models. Okay, our models, which is now the important here is a nozzle and operator only. Okay, so if let's say the nozzle and operator, the p-value is less than 0.05, so means that we consider the interaction is in one of the important component into the ANOVA table. So you cannot get the two-way ANOVA table without interaction. They only pop up only one ANOVA table. Okay, so this one it just only have the without the interaction. So for the second part, which is you have a Gage R R here. Okay, so inside the Gage R R table, okay, so sorry, I go back to this one. Okay, Gage R R here. Okay, so we have the sources, which is a total Gage R R. Inside the total Gage and inside we have a repeatability, reproducibility. Okay, and then we have a part to part. So which is let's say part to part more than total Gage. So we consider that this measurement is acceptable. Okay, part to part more than total Gage R R. So which is 99 more than 0.8. So which is we consider that this one is the acceptable, or you just proceed with this one is a less than 1%. Okay, 1% meaning that is acceptable based on the AIG standard. Okay, I go this one. Okay, so this one is 1% or less is considered that is acceptable. So go back for this one. This one is a less than 1%. So we acceptable. This measurement is acceptable. Or you don't want using this percentage contribution, you can go for the second part is a Gage evaluation. So inside the Gage evaluation, you have a standard deviation. You have a standard deviation, okay, a study variation, sorry. And then you have a percentage study variation. And then you have a tolerance. Since we include the tolerance inside the dialog board, okay, here, okay, we have a tolerance, okay, so they pop up the tolerance. Okay, so same step. If let's say you go for the total Gage R here, okay, it's less than 10%, less than 10%. So we go back to the AIG standard. It's under 10%, the measurement system is acceptable. Okay, and then we go for the next one is a NDC, number of distance category, which is 50. It's a big, more than 5. Also, we go back to this one. So if let's say it's 5 or more, system is acceptable and distinguish between the part. Okay, so we have another one. Okay, so this one is, so we go back to this one. We have, if let's say you are looking for the graph for easy, maybe easy rather than see the number here. Okay, maybe it's easy, which one is a bigger one. So maybe you can go for the graph. Okay, so you can see that part is a more than Gage R R. So this one is the measurement is acceptable. So if let's say you see that the total Gage here is a combination from the repeatability and reproducibility. So if let's say you're looking for the Gage R R here, is a totally more if from the repeatability. Okay, for let's say from this total Gage, you can see that where measurement coming is from repeatability or reproducibility. So if let's say reproducibility more than repeatability, meaning that this one is a refer to your operator side, because during do the repeatability we have a different operator. Okay, and then here is the R and S bar chart. Okay, so R and S bar chart, which is a consistent between this one. Okay, this your operator, so it's a more than control limit is a good one. Okay, and then here is the your part. Okay, so every part is not different. Okay, it's the same thing. And then if let's say this one is for the operator, which is operator 1, operator 2. So if let's say you see that the mean of this one is not a little bit differences between operator 1 and operator 2. So also interaction between part, they have differences between operator 1 and operator 2 for every part here. So this one is a reflect to this one. Okay, if let's say you see that this one is significant, so maybe for this graph you can see that differences between the operator and the part for each part. Okay, so we go back to this one. Okay, so maybe the component of variation chart clearly represent the gauge and R is the output. The differences in the part account for most of the variation. So this one is we can see that the part is higher than gauge R and R. Okay, so from the R chart, since all the point are within control, the operator consistently measure the part. And then the as far as many points are above or below the control limit, this indicator that part to part variation is much greater than measurement device variation. Okay, so this one is multiple measurement for each part. Okay, we have an iPad. So average varies enough, so the differences between part are clearly. Okay, the operator appear to be measuring the part consistently. Okay, so you see that is one. What I say that. Okay, the line follow one another closely, and the differences between part are clearly. The operator seems to be measuring part similarly. Okay, so this one iteration. Okay, so this one is in complete set for the interpreting part for the cross validation. Sorry, for the gauge and art. Okay, so this one. Okay, so I will do again. Okay, go to stat, go to quality tools, go to gauge study, go to cross. Okay, so if a nozzle is a part, the operator, okay, your measurement. So if let's say you have an option here, so for this one, I just proceed with the upper spec limit. We have tolerance here, and then this one, and then click OK. So you get the result. So from here, you see that nozzle and operator means a part and operator is not significant. So they come out with the new ANOVA table. So which is a nozzle and operator is a significant. So you go to the gauge R and R table. So from the gauge R and R, maybe you are looking for the percentage contribution. The total gauge here is a less than 1%. So based on the IEG standard, this measurement is acceptable. If are you looking for the tolerance or percentage study variation, so this one is the less than 10%. The measurement system is acceptable based on the AIG standard. And then if you're looking for NDC, so it's a more than 5. So we all say that the measurement system is also acceptable. So this one is the graphical presentation for each component here. Okay, repeatability is possibility. Okay, so this one is how you do the gauge and R using the step menu. Okay, We also have another way to do the Gage and R. We using assistant menu button. Okay. Okay. Assistant is a pick appropriate statistical tools. Is easy for you because they provide you step-by-step guidance. And then this one is maybe ensure your success do the uh, analysis, and then maybe you are run your analysis quickly and easily because the dialog box is simple less rather than step menu button. Okay, and then they give it you interpret your result with the confidence, which is they provide you summary report, variation report, and then report card. And then maybe is once you have the result, maybe easy to you share your finding with the one only click. So I go directly to the Minitab interface. Okay, I use the same case study here, but different menu. For to get to run the Gage R R, go to assistant. Okay, you see that the measurement system analysis here. Okay, so if let's say you are measure, okay, they give it what is the measurement, what is appraiser. So what different that one? So you can go for the data type here. Okay, so what is the measurement? Measure a characteristic of a part or process, such as a length, a weight, or temperature. Or appraiser, we call that the classify people, things, or event into the two categories, such as a good or bad. So this one is a difference between measurement and appraiser. So they give it you some step before you go further. So for this case, we have a diameter. So for this one is we consider is a measurement. So you go to another one is the objective. So what is the objective? So objective, you go set one is we have a two here. Maybe you want to set up a study. You want to do the custom worksheet. What I show the first step to do the worksheet. And then, or maybe you have already your worksheet. You want to just only proceed with the analyze. Okay. So for this case, we already have the worksheet, so we go for the analyze. But for assistant menu button, we just provide for cross analysis only. Nested and expanded is not available for measurement system analysis so far. Okay, so go for the cross. So your operator is operator. Your part is the nozzles. Your measurement is your diameter. Okay, so maybe this one is just estimate only. Okay, and then this one is your tolerance is a 8. Okay, and then click OK. So you get the summary report here. You get the summary report here. You get the variation report here, and then you have a report card. So this one is the differences between the from the step menu button and assistant menu button. Okay, so I redo again. Go to assistant measurement system analysis. You choose cross. You choose the operator. Fill out the dialog box, nozzles, diameter. Just proceed with the estimate, or strongly recommend if let's say you have historical standard deviation. Okay, and then you enter the tolerance here. You click OK, and then you get the summary report here. The best thing for the assistant is they have this table. Okay, most of our customer really like for this features is this one. Okay, can you adequate assess process performance? Okay, so this from here we see that is 9%. The measure system equal to 9% of the process variation. The process is estimate from the part in the study. Okay, so they have a study information, and then they can use sort the good part from the bad part. So if let's say you see that this one is a measurement system variation equal to 80% of the tolerance, and then this one is they provide you the guidelines. Okay, is 10 less than 10% is acceptable. Okay, this one is unacceptable, and then they provide the comment here. So let's say you want to add some comment again, so just double click Okay, double click and then maybe prepared by Sulawati. Okay, click OK. So maybe you have want to add and then click OK. Okay. And then you have the variation operator. Let's say it's a reproducibility for the operator by interaction, query test, and then they have also for the table, what we see in this method. Okay, I have to go split this one. You can see that the differences between this part. Okay, this one is from assistant. This one is from the start menu button. Okay, so the same style, if let's say you want to share, just right click, send to Word, send to PowerPoint. So for example, I go to send to Word. Okay, so you already send the report on this Word. Okay. So go back. So same goes for this one. If let's say you want to send the Word, already can. Okay, so for this one. Okay, so this one is the differences between Gage from the state menu, okay, and then assistant menu. Okay. Okay. For the summary here, performing a Gage R R study can help to identify problems with your measurement system, enabling you trust your data and to make data-driven decision for process improvement. I'm highly recommend if let's say you want to do control chart before you go through control chart, before you go through capability, before you go through for the optimization, let's say for design of experiment, you try do the Gage R R study first, because from there you see that is it your machine, your operator, is it a fit to do the process? Okay, this one is uh, one of the problem. If let's say you have during you do the control chart have a lot of variation or something that one. Okay, so maybe you can start with the Gage R R. After your measurement is reliable, you can go to measure your uh, process. Is it in control or out of control, in control state or not? If let's say your process already in control, you can go for the capability. Is a capable or not your process? I think it's a good one. Okay, so do you have any question? If let's say you have any question, please type them into the uh, question box in your control panel. Okay, we have a lot of question here. Do you have any office in Batam? So far, we doesn't have any office in Batam. But if let's say you want to ask something like question, you can email us directly. Okay. Will you provide the soft copy? Okay, I will send to you your email if let's say you want get this soft copy for this webinar. So, but you need to leave it your email first. Okay. What is the difference between short-term and long-term process variation? This one is, let's say, is a part to part. It's a material. It's a coming from, for example, it's material inside. Okay, so let's say I say that we do the something like cake. We need to combine a lot of ingredients, something like one. Okay. For descriptive static, which type of analysis should be used? Destructive testing goes for the nested analysis. Okay. What is historical standard deviation? Historical standard deviation meaning that you have already the old data, previous study. So this one we call it the historical standard deviation. Okay. we require to remove any outlier and run the study against? This one is the first, if let's say the first time you do the uh, experiment, maybe you need you need go through first. Okay, go through first, because from there you can see that from where the outlier coming. Okay, maybe from machine, maybe from operator. Okay. Okay, for others, I go, sorry. For others analysis, if let's say you more learn about the Gage R and R, okay, others analysis something like nested or expanded, maybe we encourage you join our training part, okay, to get more. Not only we focus for nested expanded, we also provide you how to do the, let's say for the attribute agreement analysis is something like Gage and R, but your data is a text data, let's say accept reject. Okay, for this one is we call it the measurement data. Okay, this one is the meter length. Is we call it the measurement data. So you can proceed with the Gage and R. But if let's say your data is something like accept, reject, yes, no. Okay, go and not go. So you can get the same thing but different analysis site. Is we call it quantitative attribute agreement analysis. Okay, but I not touch it for today because we have limited time to do this one. Okay, just I'll proceed with the cross verification. Okay. I think if let's say I don't not enough time to cover all your question, maybe I can email you to clear part of your question. Okay. Okay, if let's say you want more from us to join our webinar, maybe you can follow us through the media social like Facebook or link. From there you can get when the upcoming event, okay, the tips from us, okay, to handle this one. Okay. So before I stop here, I want to repeat again, we have a two availability, whether you want to go for the start. We go for the quality tools, we go for the Gage study. Okay, go for from the Gage study, we have the cross, we have nested, we have expanded. So this one is for the precision side. If let's say you want to study about the accuracy side, you need go for the linearity bias or time one case study. If let's say your data is a text data set, you can go for the attribute agreement analysis. If let's say you're not sure about this one, you can go for the assistant, go for the measurement system analysis. Okay, and then you can see that here is the Gage R and R study, and then here is the attribute agreement analysis. So what is the attribute? This one is the appraiser data set. This one is let's say is services. Okay, so it's familiar with the accept reject or something like that. One is a good not good, or let's say you are evaluator, something like that one. So you can go for the appraiser data. Okay, so this one is appraiser data. Okay, so I think okay. So if let's say you interest to our product Minitab Statistical Software, or you want to interest to join our training to learn more about the Gage and R or learn more about the measurement system analysis, so you may visit our website www.minitab.com or www.visits.com, or you contact us or email us to sales@visits.com or minitab@visits.com. Or if let's say you want to get some tips and tricks on our Minitab product, please follow us through media social like Facebook and link at Minitab Malaysia and Singapore. Or you want to access back our previous webinar, please don't forget to subscribe our YouTube channel. Also the same name, Minitab Malaysia and Singapore. So really appreciate if you fill out our survey in order enhance our webinar session. Thanks and stay safe.